Hey everybody, welcome to Chapter 7, Viruses and Malicious Code. Um, I really want you to spend some time reading the book this week because this chapter has a lot of really good information about viruses and uh, the past and uh, how things were actually created. And you're going to get a lot more out of this chapter by going into the actual chapter itself. So please take time to read the chapter. It's going to be beneficial to you in your understanding of viruses and malicious code. And this is really one of those kind of core things that you, as a cybersecurity person, needs to know. So again, please take time to really kind of dig in. We're going to go across through the slides, but the slides are not going to be as detailed as the book, especially in the examples. Look at the snippets, look at the call outs, because they have some really good information in there. And to be honest, this slide presentation would be about 7 hours long if we went into every one of the viruses and went in depth of how things kind of changed the world. So we're going to keep this at more of a strategic level and follow the slide set through. And with that, let's begin. So we're going to identify and distinguish the various types of viruses and malicious code. I want you to understand the differences between a file virus, a boot virus, macro virus, and network virus. Understand the difference between a virus and worm. Additionally, understand how a worm operates in comparison to a virus. And then understand the definition and operation of Trojans. Describe adware and spyware. Describe and understand other types of malicious code you may run into in your field. Describe and understand the true threat posed by viruses, and understand who the virus writers are and why they write viruses. So we're going to talk about each one of those. First of all, the PCs, when they came out and you had disk-based PCs and you had floppy disks, that's really where viruses started. The very first computer that took external media opened up the opportunity for someone to place something malicious onto a drive. So a 5 1/4 inch floppy disk or a 3 1/2 inch floppy disk could be easily infected and then passed around within the organization. We didn't have the internet. This wasn't internet-based viruses. This was they call sneaker net, where people would walk disks, to and fro. But as they walked those disks around, they would infect those computers. Now, obviously, you didn't have the avalanche effect going on, where you had massive amounts of computers being affected in a few hours. But what you did have is you had organizations that were specifically targeted, and then that targeted organization would then suffer a consequence. You also had something called revengeware, and we'll talk a little bit more about revengeware as we go. There was also no centralized database at this time that said, hey, this is a virus. We didn't have signature databases. We didn't have really any antivirus. And then when the antivirus programs started coming out, there was a lot of conspiracy theory going on. Just, people would say, well, it's really funny that Symantec writes a patch and, they seem to know where this virus is coming from. Maybe they're writing the viruses. So there was a lot of that kind of stuff coming out in that time. Malicious software or viruses, their code, they have a specific package. So technically, a malware is just an operating or a piece of operating code or a piece of software that's written to do a very specific thing. The code itself is not the problem. It's the intent of the code. So the intent of the code, as we've talked about intent, and we've talked about intent as we've gone through other blocks, is to either damage, provide exposure to some outside entity possibly, or exploit vulnerabilities on that system, such as a program or access to, etc. You're going to hear people refer to viruses being in the wild. And this term just means that they're talking about the propagation of viruses as it transits across the internet and goes from user to system or from system to system. Uh, when we first started seeing viruses in the early 90s, we didn't have a mechanism to track how many computers had been infected. There was no centralized database. There was no central law enforcement agency that was looking at viruses on computers. It was looked at more of a nuisance or an inconvenience, or somebody doing something malicious, but it really didn't rise to the level of criminality at the time. So the focus, there wasn't a great focus on it, but people started getting virus packages and virus protection software to prevent from having the hassles of a virus being on a computer. And that changed as things got more destructive and intellectual property started being stolen. Banking systems were compromised, and then things really started changing in the world of viruses, and it became a criminal activity. Um, so a virus is very simple. It's a program that delivers a single payload. It has a specific point where if someone clicks on something, it will activate that program. For example, if you get a picture and that picture happens to be an exe file and not a JPEG or some other picture file, and you click on that, that executes that program. And when that program executes, it goes into the system's memory and it starts doing what it's supposed to do. Now, the virus software is supposed to read through that email and catch the signature or the picture of that file, basically. What does it look like? Here's its signature. It's in my database of known program signatures, so therefore that's probably a virus. There were a bunch of different ways that or methodologies that were used to track viruses. One was by looking at the actual file itself. Another one was looking at basically a signature file for that file. So if I had a known Windows DLL program, that should have a specific MD5 hash or a specific hash value. And I would compare hash values, which is a very quick way of finding out if something has been changed in a file. So there was a bunch of different mechanisms, a bunch of different ways of being able to look at and identify these viruses. The very beginning DOS-based viruses were TSR, which means they would terminate and stay resident. In other words, they would go away. You would think the program was gone, but it would stay resident in the memory of the computer. And when you reloaded your computer at the DOS boot up, it would work its way into the boot files, and it would either load up as a bat, it would load up out of the boot IO, it would load up out of one of the boot applications. There was even firmware TSRs back in the day that would actually load up out of the firmware. So you could actually get a virus inside of your actual boot code. And that's really rare now, getting boot code, because the firmware is pretty well protected, especially on the newer systems. But that was a pretty easy way of getting viruses into the system at the day, or back in the day. Once a computer virus loads, sometimes what it would do is look for its signature or look for the program that's supposed to detect it and rewrite itself as it loads to make sure that it avoids it. And that's called a polymorphic virus. And a polymorphic virus can rewrite itself to avoid detection. It can also erase its implementation on a system. It can clean the registry, for example, and take out indicators that would allow us to go back in and see whether or not a virus had been loaded or installed into a specific computer. That also takes away some of our detection methods, as we're using registry checkers and we're using snapshots. things such as that to look at systems to see if systems have been compromised, well, then we might have an issue with that if it's going back and resetting the system back to that point, so we can't see any changes to that system. Um, and like the bottom bullet says, the viruses range from harmless, goofy stuff where a smiley face pops up on your screen, says "Have a great day," to dangerous and malicious ones, ones that cause either physical harm to your system by crossing circuitry the way that causes something bad to happen within the motherboard or within the disk. Back probably 97, 98, the drives back then could actually be reverse spun. There was a command that was left in on the Seagate drives, and you could reverse spin a drive, which caused massive destruction to the drive, basically rendering it useless. So there's a lot of different things you can do with viruses depending on the time frames you're working on. Today you don't have that issue because you don't have moving architecture in most systems. So again, they go from harmless, jokes to more malicious software. The early viruses, obviously, super easy to detect. The Pakistani brothers that wrote Brain, they actually put their business card inside of the software itself. They really weren't trying to create a virus that would spawn across the world. They were kind of experimenting and kind of playing around with the technology. If you read a couple of the interviews, some people say that they were trying to get their name out there within the industry so somebody would hire them. So a bunch of different kind of theories on the brain virus. But again, it's one of the first viruses that was a boot detect or a boot virus, and it was very effective. I mean, it made it onto a lot of computers. As we learned in Chapter 3, the reason we have crime is because we have less capable guardians. We have a growing pool. So this applies to our conversation here, the rapid growth of the internet, rapid growth and the availability of PCs, the polymorphic engine, or the polymorphic engine, which allowed for the virus to change its form while it was loading up. And then the availability of virus creation tools really aided the spread of viruses on the networks. In 1992, you could get the Virus Creation Lab, which was a set of tools that allowed you to create your own virus. So if you wanted to write a virus, you could download this application or get this application. You didn't download it at that time. You would get this application, you would buy it, they would come on a disk to you. Or you would go onto one of the bulletin boards and hopefully find it on a bulletin board. This was also very common with what we called revengeware. At this time, we also had Revenge Pack, we had revenge software, and basically what that would do is you would install that on someone's computer, and it would do crazy things to their computer. It would cause the old monochrome screens to fluctuate a little bit, and it would actually make you feel seasick if you were watching the screen. If you were working in Word Perfect back in the day, you'd be typing along, and then all of your fonts or all of your letters would start wiggling, and then they would all fall to the bottom, and there would be this big pool of letters at the bottom of your document, which was very disturbing to most people. They used to have one where this little worm would appear, and it would run between the sentences, and the more you typed, the more worms you had. Not so much malicious, just aggravating, but they called it revengeware, and revengeware was a very popular tool set, and Revenge Pack was downloaded extensively. But one of the cool things about Revenge Pack is Revenge Pack created something called the remote backdoor or remote screen viewer. So it was actually predecessor to RDP, Remote Desktop Client, where I could actually uh, jump onto someone else's computer and see their screen. Well, this virus allowed me to do that, allowed me to take over someone else's screen. And what's funny is with the software, with that software, and with a couple of other viruses that came out during the time, those actually became really great administration tools. So the virus was turned into a administration tool. So it started out as a virus, and then it was turned into a administration tool for people to help other people. So it's kind of cool how they changed that around. Most code, as you know, gets transmitted across the network now. And it's the responsibility of the firewalls and other tools that are on the network to do the initial scan to see if they recognized certain features of viruses. And then the second layer is your desktop security, making sure you have implemented some type of desktop virus software, whether it be Microsoft's Defender or Symantec or Norton or Kaspersky or any one of the large virus detection software programs. Viruses can be categorized based on the environment they operate in. So you have Windows viruses, you have Mac viruses, you have different types of viruses that are a part of an operating system. You also have the technology that they work in. So when we talk about the environment, we're not talking just about the operating system, we're also talking about the technology availability. So in a virus operation, your four basic components is a file virus, the boot virus, a macro virus, and a network virus. Each one of those has a unique component with the operating system. So if you're running a Windows back in the day, if you were running a Windows 98 with Microsoft Outlook tools, you were at great risk of getting a virus because most viruses at the time were written for that operating system and that set of tools. If you were running a Mac computer, and at that time you really couldn't run anything Microsoft on it, you didn't get any viruses. And this is why Apple has always been said to say, oh, we don't have any viruses. Well, they didn't. But now people are actually writing viruses for that environment, that operating system. And they're still looking at how to implement it in the four methods of file viruses, boot, macro, and network, but they're looking at the type of operating system that it's actually going after. All right, so file viruses, they use a particular operating system, but they also use specific files on that operating system. So just because you have Windows doesn't mean it's going to automatically work. You have to have Windows and typically an application like Word, Excel, Outlook, one of those types of tools. If you have Windows and then you have Microsoft's Edge, you may be at greater risk than if you had Windows running Firefox or Windows running Chrome, because people may not write viruses as much for Firefox and Chrome, they may write it for Edge. So the operating system allows some access, but then the application that it's using to launch has to be available as well. I can use system tools or system components to launch my virus, but more than likely I'm going to use the operating system in conjunction with a application or something to make it work. And these are things that you may want to take in consideration as you're going through and you're looking at your cybersecurity plan, is how do you protect the users from becoming victims of being in a common configuration. Maybe there is a method or a way that you can change the browser or some tool within there to help protect your users. we at our company, we changed over to a different browser, and by changing over to a different browser, that helped us. And then we went to Thunderbird as our email client, and that helped us out dramatically because we didn't get the same viruses executing that were being executed on the Outlook. That with user education, we've been able to cut down our virus infections quite a bit. Um, except for that one employee who just clicks on anything that has a picture symbol, and you just some people you just can't train. It just is one of those things. Frustrating, but you'll run into those people as you go through your career. The boot viruses. Okay, so a boot virus attacks the boot sector. It actually gets into the bootloader files. And every time the system boots, before even the operating system comes up, that virus is already active and in the system. So really the only way of getting around a boot virus is to boot from another separate operating system. So you'll either use a thumb drive or a DVD to boot the system, and you'll bypass the boot on the primary drive so that you can load tools to get rid of the boot virus. Boot viruses are a lot less prevalent today than they were because we have so many protections on the firmware and the bootloaders themselves. Microsoft inspects that bootloader before it loads the operating system. If it's been changed, it's going to warn you. The firmware on most motherboards checks the bootloaders to make sure that some firmware virus is not going to be implanted on the motherboard itself. So there is a lot of things that are going on now to protect the hardware and the software on the computer systems themselves. Macroviruses, so if you've ever hit or been in Excel and you want to run a function over and over again, let's say I want to print a certain area every time, so I set up a macro of Control-Alt-1. Well, when I hit Control-Alt-1, it runs a macro that runs through all the command strokes that would create that print job for me, and it would shoot it out. So what a macro virus does is a macro virus loads into the normal dot file, and when it gets into that normal dot or replaces that normal dot, it has a set of macros that are available that can be run by command or by app or by instigation of a file that's being loaded into the system. So I may load a Microsoft Excel file that has built-in macros, and if I have macros enabled, it may automatically launch those virus files, which then infects your system. So macros are, if you have macros enabled on systems, be very careful because not everybody needs macros. You may want to restrict macros to just certain people or certain applications that to prevent possibility of these macro viruses or these macro viruses being installed. Network viruses. Unless you're growing up in a cave somewhere, you know about network viruses. Network viruses come through email. They come through pictures we download. They come through social media that people are sending to and fro. They come from fake websites that people go to. They come from spawning websites where someone goes to a website they think they are supposed to go to, and it turns into a spawning website that spawns hundreds of pages of stuff onto your browser, and it just keeps filling tab after tab after tab. And some of those are viral web pages, so you may end up getting viruses from the avalanche of spawning websites. The biggest thing about network viruses is because they're on the network, you have a second layer of control where you have standalone computers. Your control is make sure the user doesn't plug something into their computer that's stupid. On a network, though, You have the network layer, which can protect the systems or the clients nodes that are attached to your system. So from a network perspective, you have a second layer of protection. So we have this overarching layer of protection that protects the layer just below it that keeps that client layer safe. So those are going to be your firewalls. They're going to be network-enabled virus scanning systems. This is going to be your protocol of how you're going to look at the internal parts of your network. So as a system administrator or as a cybersecurity administrator or manager, you're going to implement policy and procedures that's going to regulate the collection and examination of the network on a periodic basis. So you're going to make sure that people are not just sitting on the web or sitting on the network without any type of protection. You're going to make sure all of your systems fall under your cloak so that you can protect and keep code off of those systems. Now, this may cause issues. You may have people that come to you and say, hey, I can't get this PDF file. It's been sent to me 100 times. Well, then you have to have an alternate system. You still got to take people into consideration. So there may be times where you need to transfer code from one system to another system, but have a secondary system where it comes to a secondary system. That system is then scanned, then the PDF file is transferred over to the user. If you don't, what's going to happen is they're either going to come up with a hole that they can get into, like Dropbox or something else. They're going to download the PDF that way, infect your system, or they're going to go home. They're going to get the PDF from home, pick up all the viruses they have from their home PC, bring them into your network, and they're going to sneak them onto your network. So if you block someone from being able to be productive and do things, understand they are going to work against you to open up a hole to allow them to do what they need to do. So you always have to be very careful on taking away privileges. If you take away a privilege, give them a methodology to be able to get that information somehow, okay? And you'll find your life will be a lot easier. All right, we talked about a computer worm. A worm is a freedom-seeking thing. It wants to get away. It's a standalone piece of code. It doesn't require users to do anything. The worm seeks freedom. It wants to go to other devices. It wants to go through the network. The first known worm was the Morris worm. The Morris worm was able to get out and infect 200,000 something systems. The Code Red worm, in a span of 9 hours, blasted across the internet, and it was extremely destructive. So these worms, depending on the complexity of the worm, depending on how the worm is written and how the code activates itself, will depend on how effective it is. Worms seek vulnerabilities. If your system has vulnerabilities, they will take advantage of that vulnerability, open that vulnerability, and do what it can to keep that hole open so the other worms behind it can continue to spawn from your system to other systems. Once it hits the next system in line, it's going to do the same thing. It's going to create a hole, and it's going to go to the next system. So all the worm does is dig. It digs through your network. It digs its way out, looking for a way to get to freedom. And that's the best way. Someone told me that one time, and it stuck in my head because it makes the most sense, because that's what worms do. And worms can have viruses in them. Worms may just be information gatherers. There are times where a worm will go through a system just to see what your vulnerabilities are, then report those back so I can launch a malware application that takes advantage of your systems through the known vulnerabilities that the worm found. So the worm can be a pre-attack tool used by people wanting to do some type of cybercrime, or some people that are trying to do terror or digital terrorism, or maybe someone that is just trying to break into your system. So you may have that pre-attack tool. If you find that pre-attack tool, that's great, because now you know you've got an attack coming. You need to lock down the fortress until you figure out what the worm is doing and how the worm is doing it. If it has a virus, the virus is going to come with a payload. The payload is going to be designated to an operating system, and it's going to be designated to a type of application. Code Red worked really great if you had a Windows operating system and Microsoft Outlook. If you didn't have those two things, it didn't affect your system. So again, having systems that are not always the classic configuration is not a bad thing. It actually can be a very good thing for you, especially in the world of viruses and worms. All right, so a Trojan horse. The Trojan horse is a program that is placed onto a computer. It looks like a legitimate computer or a program, but there's some kind of backdoor to it. There's something that allows me access. There's something that is placed on the system to give me remote access to your system. So I might give you, for example, a game, and I'll tell you, hey, this is the greatest game ever, and you put it on your computer and you launch it and you're like, wow, this is a pretty cool game and it's free. And while you're on your game, I have a port that's open that allows me to RDP into your computer, and when I open up that remote desktop, I now can take your computer over. There are lots of different Trojan horses. Trojan horses are used extensively by folks that call you that say they're from Microsoft, and they say, hey, I'm from Microsoft, type in this URL, we're just going to check your computer, and what you've done is you've downloaded a program that's going to run, make it look like you're having diagnostics done. And while that diagnostics is going on, they're coming through the back door looking for your Quicken Books files, Excel spreadsheets, documents, etc. Things that they can extract quickly. Okay, and that's a lot of times what people are looking for. They're looking for those pathways to your intellectual property. They're not going to download your entire computer, but they are going to download those things that are specific or very important to your system. Different types of Trojans you may run into. Remote access Trojan, just talked about that. Password sending Trojan. So this may go on to your system and it looks for Firefox. It grabs the Firefox password list and it extracts and sends it out. It may go in, download your SID file from your Windows system, and it will send that out. There are different things that password sending Trojans will do. Again, looking for specific applications. So if I know the application set you have on there, again, who knows that? Oh yeah, the insider. We've talked about the insider threat. Password stealing Trojans may come from someone with knowledge of the inside of your network, or an insider. Keyloggers. I want information. I want password pairs. So let's say I can't get your passwords through this Trojan. So now I put a keylogger on your computer and I look for password pairs, or I look for text that's used in conjunction with each other in many different locations. So I'm looking for password pairs. So one thing with another thing, now I have a password pair. Destructive programming goes in, wipes out a drive, destroys your documents and settings, erases your registry, does something bad. DOS attack, a DOS attack, denial of service attack. So there was one. It's kind of funny, but it's not. Once we found it, and we used it kind of a lot back when we were in the automation area. But what it would do is it would take a picture of your desktop, put the picture back on your desktop, and then disable your icons. So it looks like your desktop's there. It looks like all your icons are there, and you click on an icon, nothing would happen. So what they would do is they would call customer or automation support. They'd come down, and when they came down and they logged out and logged in as the administrator, it would re-enable the icons. So the icons would be there. You click on it, boom, it would work. User would get back on there, and there would be no icons. And that was a fun one. It was kind of more of a joke one, but it's a denial of service attack, not letting people go to work. A proxy or a Wingate Trojan. A proxy Trojan is dangerous because what a proxy or Trojan does is sends all your traffic through a proxy. So if I want to listen to what you're doing, if I want to gather, wiretap your network, for example, a proxy Wingate Trojan will allow me to gather all of that information that's being sent through that proxy and be able to extract, the data with a sniffing program like Wireshark, something like that. I can then download that structure. And then software detection killers. If I know that you're running semantic, I can run a tool that will disable your virus protection. So you think you're being protected, but instead we've disabled it and you are unprotected. Um, Adware and spyware. So think about where we are today in our world. We are in a world where we are being monitored by everyone. Okay, so our capitalist society, everything we do in this capitalist society is being monitored and tracked. Okay, it's called surveillance capitalism. And what they do with that surveillance is they track and provide information to other organizations that allow them to use that information, sometimes against us and sometimes for us. So an adware program is basically a program that's going to give you ads that are relevant to what it is you shop for, what it is you do, where it is you go. There's adware is a sometimes considered to be kind of a hassle. It's cookie based most of the time, but if I go to Home Depot and I buy a tractor, the next time I go to Home Depot, they're going to sell me tractor supplies because they know that I bought a tractor, so they're going to try and give me something to go along with the last thing that I bought, which is the tractor. Spyware applications are different. A spyware application sends specific information back to publishers so that they can market to you. So where adware is kind of personal and it's on your computer and it tracks you, the spyware tracks a lot of people and it forms groups so that we can go in and we can micro-target groups of people. So I might want to send a group of people a specific targeted marketing message. I may also want to market to a group of people without them knowing that I know who they are. So a spyware program is something that allows me to listen to you and research you, where an adware program basically takes what you've done and adds complementary items to what it is you're buying and what it is you are looking for. And again, spyware programs can be used for different things. So I can put spyware programs on your phone. I can put spyware programs on different things. And then if I am a hacker or someone doing illegal content or illegal things, I can use that spyware to monitor your email, your text messages, video, etc. So I can manipulate the spyware to do things that you may not want me to know or do. Okay, so spyware, again, yeah, it collects, it works in the marketing world. Spyware was created for the marketing world, but it has flourished in the cell phone world as being a tool of control, and it has flourished in the computer world as being a way to micro-target groups of people or populations of people. Denial of service attack, we've talked about this quite a bit. Just real quick again, it's kind of like trying to get into a single store or a single door at a store. If I put a bunch of people in there, all tracking through that door, you can't get in. I've denied you service to that store. Same thing happens on the hubs and switches and routers around the world. I send so much traffic to that one server using my zombie machines, and a zombie machine is either a knowing or an unknowing computer that's on the network that has one specific purpose, and that's target that that computer that I'm attacking and send it so much traffic that it just can't do anything about it. Okay, so a denial of service attack, just like it says, denial of service. I'm taking away your ability to be able to get into a service or take advantage of something you might have paid for. And that is a crime. Denial of service attacks are seen as computer intrusion, and it is a crime under the federal statutes. So when somebody is attacking your network, so you're the manager of this network, and you're looking at attacks coming, you're probably not going to get a singular attack that's going to hit, boom, it's over, done. You got time to diagnose and look at the problem and see what happened. You're going to get what's called a blended threat attack. And a blended threat attack just takes all of the things that are available and throws them at you all at the same time. So a blended attack could be like a bot program. And a bot attacks and it does a pre-attack with a worm, followed up by a polymorphic virus that's been written for your operating system and your tools, which is then followed by a spyware program that's left behind to watch the actions on the network to see what it is you do in response to my attack. So there are many different ways of being attacked. You just need to make sure that when you are working on the solution from an attack, you need to make sure you're not still under attack or another attack, more compromising attack is going on as you spend your time working on the first attack. The blended threat is probably the most common method to access and go after networks because it ties up your engineers. People are spending more time looking at the first one. They're not worried about the second one. And the second one is the one that has the more destructive code, and it ends up causing the most damage. So always look for multiple attack vectors. Always look for the blended collaboration of different mechanisms, different programs, all coming in either at the same time or one right after another, learning from the one that came previous. Viruses and malicious code attacks are not going to go away. They're going to get worse and they're going to get more complex. Why? Because our technology is getting more complex. The more technology we have, the more complex the technology is, the more we're going to need to be accessing larger storage containers like the cloud. Well, with that being said, that means I'm going to have some type of connectivity. With connectivity comes risk. So the ability to steal information, intellectual property, do banking fraud, things like that, just becomes easier in a more complex environment because we are so tied to that environment that we can't just say, we're off the web, we're not going to do it. So the virus or the computer criminals rely on that, or they rely on us not being able to say, stop the madness, we're just not going to do the internet anymore. They know that'll never happen. So that becomes a platform that is resilient. It's not going to go away, so therefore I should build my attacks from that resilient platform. I just need to keep trying, and eventually I'll figure out a way of getting through. And again, the more people steal, the more we have to hire massive amounts of people in cybersecurity departments. It gets expensive, and companies go out of business defending themselves. There was a thing on PBS the other day, and they were talking about 5 companies that went through disasters and never recovered because it was so financially destructive to the small companies that they just couldn't get back on their feet. They tried, but they just could not get back on their feet because they had to hire so many people and they had to do all these things to protect themselves, and they just looked at the market and said, we just can't do it. So it actually forces businesses out of the marketplace. And that also is an attack. So if you're a competitive market and you can attack a business out of business, well, then people are going to buy product from you, not from them. So all these attacks, nation state or religious or ideological or just people goofing around and being doing revenge code. These are all things that are things that cost lots of money, lots of work for people, and much time trying to patch or figure out how to protect your systems. And just remember, every time Microsoft comes out with a new patch, like it did on my computer yesterday, that means that there's a potential of a new hole or zero-day virus that can run on my computer. You have to understand when and when not to update your systems. If your system is working well and you've got it secured and a new patch comes out, don't just let it automatically install. Give it a day or two, look at the code, make sure that your systems, once they're updated, don't lose any of their protection. And that's really, really important and key in managing your networks. One theory says the motivation to virus writing changed from recognition from peers and experimentation, progressing to revenge and social notoriety. Yeah, and that's, you start out as a kid and you want some recognition from your peers. You're not really out there to do criminal stuff. And then you kind of play around. You go, hey, this is cool. I can actually do some cool stuff. And then something happens. There's a turn, and you either see a monetary gain that you just can't pass up because you know how to write this code and you know you can take this system offline, or you see a way of enacting social change. And I will tell you, in today's world, there are lots of people that feel they don't have a voice, and they're taking their voice out on the network, and they're using it to attack, political parties, religious or activities, groups of people, and they're using the tool that they believe gives them a voice, and that is the computer technology. And then we talked about this when we talked about script kiddies a while ago. Script kiddies are your most dangerous group of people because they're the largest group of people, one, and two, they don't know what they're doing. Most script kiddies take pre-compiled stuff, throw it on the computer, and think they're a hacker. They do not understand the things that they do, so therefore they can cause great amount of damage and not realize that they actually are creating a great amount of damage, and that's a very dangerous thing. So you may end up with an insider who's a script kiddie who is playing around on the network, and when you hear those words, just playing around, that should be taken just as seriously as someone that's doing a strategic hack on your computer. Companies should not look at that in any different way. And then once the curiosity changes into that kind of either that revenge or crimeware, well, then now you have your criminal, now you have your terrorist, now you have your freedom fighter, your ideologist mentality going, and now you're going to have someone that's a lot harder to deal with. If someone goes from a script kiddie and actually learns how to code, and they bring with them those ethics and morals of the criminal, that's going to be more dangerous to you in the future because that script kiddie can be radicalized to do things that they may not realize that they're doing, working for organizations that they don't realize they're working for. All right. So again, Chapter 7. It's a really good read. Please read it. Look at all of the excerpt boxes. Go out and do a little research on the different viruses they talk about. I think you'll find this very interesting. I think you'll find this is one of the chapters that is kind of key to your future in cybersecurity, especially. And with that, I will say I will see you in the next chapter.